Hello everyone. Our channel selects viewpoints and analytical articles from think tanks and well-known figures within the Chinese internet, and presents them to Western readers so that everyone can understand how China thinks. If you find this helpful, please subscribe, hit the like button, and share our channel. Thank you. It should be emphasized that the content we present reflects only the original author's views. Our aim is merely to enhance readers' understanding of perspectives from the Chinese intellectual and policy-making circles. In recent years, China has made the upgrading of industrial software capability a central pillar of its drive toward new industrialization, with the manufacturing sector contributing nearly 30% of global value-added output. The domestic agenda is clear: build not just hardware, but the intelligent software engines that control design, production, and operations. In that context, the goal of replacing around 2 million industrial software suites and 800,000 industrial operating systems by 2027 is not merely a numerical target, it is also a signal that domestic substitution is advancing. Under mounting external pressure and internal urgency, you, as a listener from the Western world, may find this level of top-down planning and strategic coordination unfamiliar or even unsettling. But if you approach it with a humble and open mind and listen through to the end, you may ask yourself, does this model hold lessons worth learning? Or do you see in it the seeds of fatal flaws on the Chinese end? Feel free to share your reflections in the comments below. The interesting part about the following roundtable transcript is that all the speakers are industry veterans, seasoned figures in China's industrial software field. By listening to how they speak, think, and interact, you may gain a more intuitive sense of how Chinese professionals approach questions around industrial software. Language itself is a natural barrier, especially a language like Chinese, which branched off from the Indo-European family at least thousands of years ago. That sense of unfamiliarity is almost innate. So we hope this translation can help bridge that gap for you, even if just a little. With that context in mind, let's now listen to the voices from inside China's industrial software community. In mid-August 2025, a roundtable of China's industrial software leaders gathered to reflect on policy, technology, and the path forward for domestic tools. Recently, the U.S. administration signaled it may escalate the trade conflict by targeting critical software. And in that category, industrial software stands at the center. This conversation was convened by Intelligent Manufacturing magazine under the banner Wise Minds on Industrial Software, bringing together well-known experts and company leaders for a deep dialogue on the current landscape and the road ahead. Today, AI and manufacturing are being fused as a core task of China's new industrialization. And by 2027, the plan calls for roughly 2 million suites of industrial software and 800,000 industrial operating systems to be upgraded nationwide. With the momentum of AI, the equipment renewal drive, and the scale of a data-rich economy that contributes nearly 30% of global manufacturing value added, domestic industrial software is rising to frame the discussion. The group maps out 10 focal questions, from policy-driven breakthroughs to the design principles of a new generation of software, to leapfrogging with AI, to human-machine collaboration, to empowering the mold industry, to landing strategies, to the distinct model of the Shushui mold industrial park, to routes into the SME market, to the kinds of companies best suited to build next-gen tools, and to the core factors for making digital transformation real across industries. Next, Xiaomin explains how recent policies expand in scope, are more inclusive and flexible, and set concrete targets, including the replacement of 2 million industrial software suites and 800,000 operating systems by 2027. He notes 3 levels of implementation principles. For OA portals and email, replacement is mandatory and complete. For ERP and CRM, replacement is required where appropriate. And for R&D and production software, the rule is replace where you can. Most industrial software relevant to this forum lies in that third category. So replace where you can becomes the practical guide, yet also exposes difficulty. CAC's foreign tools still dominate R&D software, and domestic share remains low, real-world obstacles will emerge. And not all targets will be easy to achieve-a-thon. Teng Dongxing shares 25 years of experience and sketches a four-part landscape. First, R&D tools are harder to swap, especially CAX suite, CAD, CAE, CAPP, CAM along with EDA and PLM, which concentrate in discrete industries and embed deep knowledge and mechanism. Production systems such as MES look easier on the surface and attract many players from universities, institutes, and small firms. Yet they are technically demanding and price-compressed, a classic red ocean. Third, business management systems like ERP and upper-layer BI are easier at the low end but remain tough at the high end, not least because data quality issues undermine outcomes and executive trust. Fourth, embedded software has seen meaningful progress. In areas like automotive and defense adds a practical distinction between targetless and targeted replacement targets. Cases like a general-purpose CAD raise questions about opening legacy files and matching the many hidden functions users actually rely on, which many companies themselves cannot fully enumerate. Targeted cases like upgrading a specific press system can be scoped against clear boundary conditions and executed decisively, underscores how MES spans fine-grained, interlocking processes, production control, planning, APS, and demands rigorous software engineering that industry teams sometimes underestimate. From the toolmaker and tool user angles alike, the work is huge. So China must lean on intelligent technologies to compress timelines. Industrial software may be a magic brush, but not everyone is Malianga. I must compensate for scarce expert capacity. Yet that is a hard problem, one that calls for orchestration by leading firms. She points to a practical approach now promoted by the ministry: build apps atop mature anchors, CAD, CAE, and others, so modular apps can deliver replacement value faster. No. Kia Shopping offers Huawei's vantage point on strategic breakout. Recalls that after May 16, 2019, when Huawei was added to the entity list, an internal audit found more than 8,000 tool products suddenly unavailable, with roughly 96.8% sourced from overseas. The company first pursued business continuity under centralized command, then shifted into an Aniwan phase of decentralized guerrilla-style problem-solving, then re-established a unified business continuity function. by 2023. Internal Wujiang breakout meetings showcase tools proven inside Huawei scenarios. Yet success in one enterprise does not automatically mean a mature product or a viable vendor ecosystem. The gains can slip, and suppliers can still fail, so Huawei pushed further, confronting a sobering diagnosis on core techniques, headcount, and investment. China's industrial software sector lags far behind top global vendors. Count around 100,000 employees. China's top 10 together have roughly 5,000. Global R&D spend runs into many tens of billions. Domestic totals are a fraction of a fraction. On response, he proposes for redefinitions. First, redefine application scenarios by fully leveraging China's rich manufacturing contexts, big data, cloud, AI, and advanced networks, and pursue scene-driven breakthroughs rather than copying every feature of incumbents. Redefine the root technologies and kernels, aim for the same functional purpose, but allow a different technical engine, just as electric drive can replace internal combustion to achieve motion. Third, redefine architecture and methods for a cloud and AI-native era. Monolithic, single-node designs struggle when computation must scale out on the cloud. Fourth, redefine the advancement model, break the stack into a grid of decoupled services and components, assign modules to different firms and institutes, and reassemble through standards, governance, and engineering discipline. He emphasizes that only an ecosystemic, systematized campaign has a chance of success. At this point, Li Hong steps back to the steel industry to explain why AI is disruptive and why software maturity matters. For decades, China prioritized hardware visible assets over software, a bias born of resource constraints and a focus on scale. He recalls importing an old rolling mill for around 1 billion yuan, declining a $20 million software offer to save money, then discovering the plant could not reach rated output without the control software, ultimately paying around $100 million to remedy the gap. Software, he argues, is a system with maturity curves, best practice accumulation, and hard-won know-how as digitalization advances. The traditional 5-layer automaton to BI stack will itself be reshaped, and long-standing boundary disputes like where MES ends and ERP begins will ease in AI. He distinguishes classic rules and data-heavy approaches from large model intelligence that changes development patterns and reduces dependence on exhaustive mechanistic coding with digital transformation. Big data, industrial internet, and large models converging, and with external pressure limiting predatory pricing that once suffocated local upstarts, domestic software has a rare window. Shushui builds on this and warns that the coming surge won't necessarily crown today's vendors. The next 3 to 5 years are a catch-up window, but over 5 to 10 firms that fail to embrace AI will likely be eliminated. Cites emerging models that embed physical laws, suggesting that models will increasingly know what they know and become explainable, an essential threshold for industrial domains. Then the panel turns to human-machine. Rolescu argues we are moving from CAX computer-aided, with humans as protagonists, to HAX human-aided, where models generate most of the content and humans provide constraints and final corrections. Steng agrees the arc is toward deeper intelligence and shrinking human intervention. With large models, the software becomes the magic brush and humans become the adaptable artists who guide its outcome. Adds that in the next 3 to 5 years, AI will drive hardware, rebuild software, compute and activate data, and control networks, putting cloud and AI as the twin wings of next-gen industrial software. He forecasts cloud-native and AI-native tools becoming mainstream. Dialogue shifts to molds, a crucible for software capability from a micro-lens. Kinke describes molds as inherently innovative. Nearly every mold is a new product and as the gatekeepers of precision and interchangeability. More than a decade, plans have labeled software the bottleneck of the mold sector. He recounts the pain of dependence on foreign tools, shifting from purchase to rental, forced upgrades, and fragile negotiating power. Yet he also sees hope as domestic design software reaches 50% compatibility with incumbent ecosystems, in some cases rising toward 80% after sustained use, making cautious adoption possible where deadlines and legacy data once forbade. Risk notes that ERP and MES in China matured alongside global peers, but in CAD, CAM, and simulation, foreign vendors still dominate. He stresses an industry trait many mold makers have founded in-house IT or digital subsidiaries to turn hard-won practices into shareable assets, pushing toward a model where future leaders will be manufacturers plus digital collaborators. She calls for a scientific manufacturing era grounded in material science, forming physics, digital principles, and simulation. Closed loop. She offers an example from extrusion molds for automotive films that can have 140 ultra-thin layers, where enterprise material research surpasses university work, demonstrating how breakthroughs start with materials and propagate through forming and design. Also argues for strong second development capability inside enterprises, talent who understand both the domain and computing so software can be adapted on the fly to process realities. As for ecosystem building, he advocates stringing beads into chains to align scenarios along the value chain so that firms receive integrated end-to-end solutions, not isolated tool sharing. This Kia reflects that the urgency in Mold's eyes wet with tears, enduring humiliation, reshapes his sense of priority, and he suggests sparing short board repair in geometry and mechanics with long board forging where industry pain points are sharpest, especially by software using knowledge and experience and by coupling AI with physics, chemistry, and materials and landing paths. Kia insists the right mindset is open not to exclude foreign tools, but to raise domestic strength under new principles. She reiterates scene-driven design, new architectures, and a federated forest versus forest strategy. Outlines for stakeholder groups. Industrial enterprises must open scenarios and contribute knowledge as software-ready assets while committing senior experts to co-creation. Core software vendors must harness cloud, AI, big data, and disciplined engineering. Universities and institutes must tackle the scientific problems that lie beneath engineering problems, and the broader ecosystem must solve the last mile. Second development integration, deployment, promotion, education, and content. Kinki adds a practical constraint for SME-heavy molds. Verification costs. You cannot ask private mold firms to shoulder validation risks that could sink a single piece. Deadline critical job. Therefore, public or mission-oriented institutions should underwrite staged validation. And compatibility thresholds say 50% with NX rising to 80% can give firms confidence to adopt in parallel before full migration. Xiaomin then describes the Shushui model. Unlike typical parks in South and East China, Shushui's physical design starts with a central factory flanked by cloud-allied factories. Aligned to a cloud factory concept from day one, the lesson is that digital transformation should begin with a future-fit physical plane. You cannot strap a jet engine onto a horse cart queue. Notes that Shushui is a Huawei customer adopting new industrial software stacks and that Huawei's industrial software cloud strategy frames cloud factories as a key paradigm. The factory runs atop the cloud, with shared resources maximizing return on investment across a cluster. He contrasts this with legacy districts of fragmented small shops, where talent attraction, succession, and transformation stall, arguing that paradigm shifts in the physical plane plus a digital plane of cloudified software can unlock high-quality growth. Goes further to predict a convergence of tools and business. I will blur the line between tool and operation. CAM, for example, will follow the machine, perform error compensation, and optimize with live data when software fuses with operations. The addressable market jumps from hundreds of billions of yuan for tools to trillions when business value is accounted for. Moreover, cloud factory paradigms finally create true vertical big data for molds or PC-brained on these shared high-fidelity datasets. Industrial AI will yield applications with overwhelming advantage. Kinki agrees on the promise but cautions that the Shushui pattern is bound to a single, integrated business, which limits portabilitizing. The wider semi-base will require new digital modes that preserve differentiation and help firms decide what to abandon and what to strengthen. She hopes AI can help owners rationalize their portfolios and escape homogeneity. The discussion turns to fundamentals for landing next-gen software. Kia singles out industrial data as the core. Kinki emphasizes fusion. Digital technology must truly integrate with the specifics of each industry segment. Too, for Maniko Systemly Hong sees two roles for software: the essential vehicle for enterprise upgrading and a platform for developing hundreds of types of digital elements. Sting offers a couplet: with cloud beneath the software's magic brush, intelligence paints the blueprint of transformation and sets the banner as collaborative wisdom. Xiaomin concludes that everything worth doing in software is worth doing on the cloud, because only on the cloud can data and software be everywhere. And Liu Jing reflects on a state where software dissolves into business doing nothing, yet leaving nothing undone, so interaction becomes natural and technology recedes into capability. Unclosing, Xiaomin ties it back to the 2027 replacement targets and the symbiosis of industrial software and industrial digitalization. The battlefield of digital industry is manufacturing, and the soul of modern manufacturing is software, soft equipment, soft components. The super digital mother machine without industrial software. Complex products cannot be designed, and without embedded industrial software, advanced equipment cannot operate. Hong adds that the best builders of industrial software may be today's industrial internet platforms, refocusing on software as their core. Enterprise digital subsidiaries maturing from tool users into capability providers. Big data firms turning models into industrial value, and emerging AI companies teaming up with central enterprise scenarios. Finally, Xiaomin observes a shared pattern between industrial software and the mold sector: small, scattered, weak, and single-piece by nature, calling for concentrated power, shared resources, intensive models, carrier group tactics, and collaborative ecosystem. Sees concentration to counter dispersionists, sharing to defeat isolationists, intensification to replace roughness, carriers to replace skiffs, coordination to complete the supply web, a reconstructed physical plane to complement the digital plane. Then can the mold industry and China's industrial software advance together. That concludes today's narration. Through the voices of China's industrial thinkers, we've explored how policy, technology, and strategy converge in the country's push to rise through software and intelligence for clarity and flow. Some parts of the original conversation have been summarized or slightly adjusted. Certain technical or context-heavy sections have also been refined to make them easier for international audiences to follow. If you would like to read the full transcript or discuss the ideas in more depth, you are welcome to reach out to us directly. If you enjoyed this episode, please like, share, and subscribe to How China Thinks. Thank you for listening and see you next time.